So 1/6 is higher ordered polynomials. So we're going to be solving polynomials that are higher ordered than quadratics. So we looked at this type already in the 1/5 section, this x to the cube. But we want to go over this process because we'll use it for ones that are higher ordered. So this says solve using the zero product property. We want to factor. We want to factor first. So to factor, I need it equal to 0. I want the x cubed, so since that's the leading coefficient is 1 here, it's positive. I want to keep that positive, so I'm going to move the 2x squared and the 9x to the left. So I'm going to add 2x squared. And then subtract 9x. And I'm going to put it in the correct order so it's in standard form. All right, zero product property means I want to factor. So how do I factor 4 terms? Okay, by grouping. What do I factor out of the first group? X squared. What do I factor out of the second group? Negative 9. Good. Okay, so they have x minus 2 is their common factor. Or, I'm sorry, x plus 2. And then I'm left with x squared minus 9 equals 0. But I noticed that x squared minus 9 can factor more. What does x squared minus 9 factor to? Good. X plus 3, x minus 3. Now that you have linear factors, and you could actually do it with just quadratic factors too, you could do the zero product property. So that's where you say, okay, x plus 2 equals 0, or x plus 3 equals 0, or x minus 3 equals 0. So x equals negative 2, negative 3, 3. Okay. The degree of this was 3, so how many solutions? 3. So you have the same amount of solutions as the degree. So questions about this one at number 16? Yes. No, that's not it. So let's look at 24. So what's the degree? How many solutions should I have? 4. So if you were to solve it like this, where you just add 1 and then take the 4th root, well, it's an even root, so it's plus or minus, and you would just get 1 here. So you have only 2 solutions, but I need to have 4. So I want to solve this by factoring. So by zero product property, which means to factor. So I see I can use difference of squares here. What is the square root of x to the 4th? X squared. Good. Okay. and the square root of 1. 1, so then 1 is plus, 1 is minus. Okay. X squared minus 1 could factor more as difference of squares, so you could do that if you want. But you can use zero product property with quadratics. So quadratics means you have x squared. So these are quadratic factors. Up here, these are linear factors because it's just x. So that's really what we like, are linear factors, but quadratic factors are fine. I can still solve those. I can still use zero product property. But not until you have at least a quadratic. So quadratic or linear, zero product property. So you could say x squared plus 1 equals 0, or x squared minus 1 equals 0. So you're subtracting 1, and then you do the square root. So remember, solving quadratics, and you take the square root, you have to put plus or minus. And then what is the square root of negative 1? I. So plus or minus I. Then on this one, you add 1 and take the square root. So plus or minus 1. So there are my 4 solutions. Plus or minus I, plus or minus 1. So you can leave it like that, it's fine. If you want to write it together, that's fine. I want to talk a little bit, though, about factoring x squared plus 1 now. Now that we have defined I, you can factor the sum of squares. So before, we knew we could factor difference of squares, but we said, oh, well, we can't factor sum of squares. Now that we have I, we can. So sum of squares factors a lot like difference of squares. So a plus b, a minus b. But this time, with the b, there is an I. So if you wanted linear factors, which in this case we don't need, further down the semester, when we factor these, it'll say write your linear factors. So you would have to factor this further. Now we're just solving, and so we can solve when it's quadratic. But if you wanted linear factors, then your sum of squares would be x plus 1i, x minus 1i. And then difference of squares, x plus 1, x minus 1. Then here's your 4 solutions. Negative I, positive I, negative 1, positive 1. Okay. This one is easier to do it with quadratic factors, but you are still able to get linear factors. Yes. Yes. Okay. Okay, let's look at another one. Okay, so what's the degree? So how many solutions? I should get 6 solutions. All right, don't worry about the degree when you start factoring. You have 4 terms, so we should factor by grouping. Okay, even though it's x to the 6th, I have 4 terms, so I need to factor by grouping. So what do I factor out of my first group? X to the fourth. And I get x squared minus 3. What do I factor out of the second group? Good. X squared minus 3. So this type of factoring doesn't always work. I mean, it will in this section, but not every polynomial that has 4 terms can be factored by grouping. Just like not every trinomial can be factored to 2 binomials, not every polynomial of 4 terms can factor by grouping. All of these will, because you have to factor it. No, they're still solutions. They're just, you're not able to find them this way. And we won't learn that until not this chapter. Okay, so x squared minus 3 is what they have in common. And then x to the fourth minus 16. So I have a quadratic x squared minus 3, so I'm not going to do any more with x squared minus 3. But I don't have a quadratic yet here. So I want to factor x to the fourth minus 16. I could do difference of squares again. Difference of squares here. So the square root of x to the fourth is x squared. And the square root of 16. Okay, plus 4 minus 4. So I know I can make linear factors here, but I don't need to do that. I can go ahead, since I have all quadratic factors now, I could go ahead and do zero product property. Set each piece equal to 0. So x squared minus 3 equals 0. Or x squared plus 4 equals 0. Or x squared minus 4 equals 0. So I have to add 3 and take the square root. So x equals plus or minus square root of 3. We're doing all exact answers here, no decimals, so just leave that as radical 3. Okay, then here, subtract 4 and square root. So x equals plus or minus, what's the square root of negative 4? 2i. So then add 4, take the square root, x equals plus or minus 2. Okay, was x to the 6th. Do I have 6 solutions? Yes. 2 here, 2 here, 2 here. Okay. Questions about that? Okay. Okay, this is one of those that can factor by difference of squares or difference of cubes. I'm sure most of you don't remember the difference of cubes formula, so let's start with difference of squares. It doesn't matter, but difference of squares is going to be easier to start with. We'll have to do both anyway. All right, so difference of squares. What is the square root of x to the 6th? Good, x cubed, x cubed. So remember why that is. So the square root of x is x to what power? The square root is x to the 1/2. Okay, so if you're doing the square root of x to the 6th, That's x to the 6th to the 1/2. So that's x. 1/2 of 6 is 3. The square root of 64 then is 8. Okay. So I have this is the sum of cubes. And this is the difference of cubes. Okay. So let's talk about those formulas. A cubed plus b cubed is a plus b. So cube roots, and then a squared minus ab, not 2, minus ab plus b squared. And then the difference is a minus b, a squared plus ab plus b squared. So this is where you only look at the signs here to know that, okay, I'm doing the sum formula. But a is just going to be x, so the cube root. And b is just going to be, what's the cube root of 8? 2. Okay, so it's a plus 2, and you follow the signs exactly. So a squared would be b squared minus 2a plus 4, b squared, which is 4. Oh, yes, sorry. Yeah, I switched my variable from x to a. X plus 2, x squared minus 2x plus 4. Yeah, thanks. Now on x cubed minus 8, again, a equals x. And b still equals 2. I'm not saying negative 2, I'm just saying 2. Because the negative 2 is already taken into consideration in this formula. So then I get x minus 2, x squared plus 2x plus 4. Okay? All right, so all of these factors are either linear or quadratic. So I can go ahead and do zero product property because I have linear or quadratic. So I can have x plus 2 equals 0, or x squared minus 2x plus 4 equals 0, or x minus 2 equals 0, or x squared plus 2x plus 4 equals 0. Okay. So here it's easy. It's just x equals negative 2. This one's easy. X equals 2. So there's 2 solutions. a quadratic trinomial, what would you want to do? Factor. Well, it's not going to factor because this wouldn't be the formula for sum of cubes or difference of cubes. So this breaks it down so it factors all the way that it can. So the trinomial attached to sum and difference of cubes does not factor. So how do I solve a quadratic that does not factor? What? Quadratic formula. Or complete the square. So let's just do quadratic formula. Okay. So x equals opposite of b plus or minus b squared minus 4ac all over 2a. When you're solving quadratic formula, just do the discriminant first, because you have to keep these simplified. We don't want any approximate answers, no decimals. So just type in what's under the radical first. And you should get negative 12. And then it's okay to do the denominator 2 times 1 is 2. Okay, so you need to simplify square root of negative 12. First of all, since it's negative, that means I pull out 12 can be simplified though because 4 goes into it. So square root of 12 simplifies to 2 square root of 3. Okay, can I simplify any more? Yes, not my radical, but I see that there's 2's. So you can either think of it like this, where you separate and your 2's cancel, or you could factor out a 2 and cancel that with the denominator. So then x equals 1 plus or minus I square root of 3. Okay, so then here's 2 more solutions. I need 6. So I have to use quadratic formula on the other trinomial to get my last 2 solutions. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you should get negative 12 again. So I know that simplifies to 2i square root of 3. All the 2's will cancel. And this time you get negative 1 plus or minus I square root of 3. And there's your 6 solutions. You don't have to write them all together. Just make sure they're circled or something so I can find them. So that one is long and tedious. We did lots of different things. We did difference of squares, and then we did sum and difference of cubes, and then we had to do quadratic formula. So a lot tied into that one problem. But our main goal is to find the solutions. We needed 6 solutions. But I had to do all of that to get all solutions of x. Any questions about that? Okay. Talk about solving rational equations. So this time with rational equations, so when you have variables in the denominator, they're not polynomials, so they don't have a degree. Okay, so you're not just thinking, oh, there's just one solution of m. There could be, but there could be more than that too. So the degree doesn't tell you the number of solutions. What I have to note, though, are those disclaimers. Now, I'm not finding the domain, I'm actually finding the solutions. But I need to make a note to myself that m cannot equal -3 or 0 So I note that because then after I solve, if I get both of those or either one of those, then that root is called extraneous. And we'll talk about that if it happens. Okay. So what I want to do, just like when I solved linear equations with fractions, if I multiplied through by the LCD, then it cleared my denominators. So I want to multiply through by the LCD so I get rid of the denominators. So the LCD, first of all, I need an m plus 3. But then I also need an extra m. So I'm solving here, I'm not simplifying. So that means what I do to one side, I can do to the other, and the equation stays balanced. I'm multiplying everything by the whole LCD because I want to cancel. So I'm not multiplying just by what's missing. I'm multiplying everything by the whole LCD. Yes?
So when do you just multiply by what's missing?
So if you're simplifying and there's not that equal sign there, then that's the only thing you can do is multiply by 1 to keep it the same. But since you have an equal sign, you can do whatever you want to one side as long as you do it to the other side. So this chapter is solving, so you're going to want to multiply by the whole LCD. Okay, so I will write out the distribution so we can see how they'll cancel. So I'm first doing m plus 3 times 3 over m plus 3. So times this term. Then I'm doing m plus 3 times this term, which is 5 over m plus 3. And then I have to do on the right 1 over m times m plus 3. Here's where I cancel. So the reason why I do this is so I get rid of the denominators. So every denominator should cancel. So here my m plus 3's cancel, and I'm just left with m times 3, which is 3m. Okay. Then on the next one, okay, the m's cancel and the m plus 3's cancel. So you're just left with what? Yep. Minus 5. Good. Okay, on the right side of your equal sign, the m's cancel. So you're left with 1 times m plus 3. Well, 1 times m plus 3 is just m plus 3. Now I have a linear equation to solve. Subtract m from both sides. Add 5. 2, and n equals 4. Okay? 4 is not negative 3 or 0, so 4 is a perfectly acceptable answer. Anytime you're solving any type of equation, any equation, you can always plug this back in to check to see if it's right. Yes?
Like how I would have questioned that, like, I
Yes.
at the top end, because you just put the answers.
Well, at the end, if the denominators are the same, so you end up with, did you end up with 2n minus 5 over n plus 3? Yeah, you can do it the other way, and then the denominators don't necessarily, they don't really cancel, but if it's the same, the denominators are the same, and the numerators have to be the same. So it's okay to set the numerators equal to each other. Yeah, you can do it, it's just a little bit more work. I mean, this is a pretty easy equation, as you can. Yeah. Yes. Did you have a question? No. Anybody else have a question? Okay. So let's look at another one. Okay, let's make our little note that x cannot equal 5. This x is not a denominator, so I don't worry about that. X could be 0. X cannot equal 5. Okay, I only have one denominator, so my LCD is x minus 5. Technically, I guess we have two denominators, but they're the same. So I'm going to multiply everything by x minus 5. So I have two terms on the left, so I will distribute. I also have two terms on the right, so I will distribute. When I do x minus 5 times x, I'm going to put the x in front of the x minus 5. Just that looks more normal than putting it there at the end. It's just easier to distribute that way. Same thing here. I'm going to put the 1 in front of the x minus 5. And then I have 2x over x minus 5 times x minus 5. Okay, now we'll cancel. So here my x minus 5's cancel, and you're just left with 10. There's not a denominator here, so nothing cancels. You have to do x times x minus 5. That's x squared minus 5x. Equals, there's not a denominator here, so you're just multiplying. 1 times x minus 5 is x minus 5. There is a denominator here, and those will cancel, and you have plus 2x. Okay, so I see that I have x squared. I have a quadratic. When you solve a quadratic, you want one side equal to 0, and you want the x squared term to be positive. So I'm moving what's on the right. I'm going to move that to the left. But let me clean this up a little bit. Let me first arrange the left here in standard form. And let me combine like terms here on the right. So that's 3x minus 5. Okay, now that I will move the terms on the right to the left, so I'm going to subtract 3x from both sides. that's x squared minus 8x. And then I will add 5. Okay. When you have a quadratic trinomial, you want to factor if possible. Does this one factor? Yes. A quick way to know, remember, is to do b squared minus 4ac, and if that gives you a perfect square, then you know that this would factor. So, factors, so things that multiply to be positive 15, that add to be negative 8. Okay, good. So x equals 5 and x equals 3. But, as I noted at the top, x cannot equal what? 5. So, this is extraneous. So 5 is still a solution, it's just an extraneous solution. So I have to see it. I have to know that 5 is still a solution, but it's extraneous. It'll tell you in the directions if you have an extraneous root or an extraneous solution, state so. Okay, it'll tell you to point out the extraneous ones. So we're only going to have extraneous ones with either rationals or radicals. So when variables are in the denominator or under the square root. Okay, we're going to do one more, so hang in there. Anytime we have variables in the denominator, we want to multiply through by the LCD. Okay, so I'm still going to be multiplying through by the LCD. My LCD will be x, y, z, right? I need all three of those covered. Okay? So, in my first group, the x's cancel, and I'm just left with y, z. In my second group, my y's cancel, and I'm just left with x, z. Okay? And then in my third group, my z's cancel, and I'm left with x, y. What variable am I solving for? Z. So what do I do here? What do I have to do so I can combine those, so I can get just a z? Yep. If you have z's on the same side, factor it out. And then, what do? I want z, so I'm close, I just have to divide by y minus x. Once you get z by itself, don't worry about trying to simplify this side anymore. It's fine. Z is by itself. That's what we wanted.